So once you have calculated your PVT and also your bottom hole pressures, what you need to do when it comes to your bottom hole pressures is that you need to pick which of them that you actually like to use for analysis. So you can either use the measured gauge pressures directly, or you can use any of the calculated pressures as well, and that will be used in all the analysis that requires bottom hole pressures. So for instance, if I have measured PWF from a gauge, you'll see that in the bottom hole pressure features that, or the feature that use bottom hole pressure, that's what will be used. But if I change to Beggs and Burls, for instance, and go to analytical RTA, you'll see that the correlation have or the pressure data legend has changed. In this case, we'll just go ahead and use the measured pressure, and we'll go ahead and go to the multiphase flowing material balance exercise, where you see that we have a lot of scattered data on the plot. And just remember that you need to click run here up to the left before you see this type of plot. And our job is to try to create a straight line relationship on this plot. What happens here is that there's this long transient period as we go below the saturation pressure, but we see that we have a pretty clear, nice trend before we go below the saturation pressure, which is this straight line part right here. And you can also zoom into this plot if you part of the plot if you like to make sure that you're hitting those points accurately. So if you come up with a slope that you're happy with, you can click run again, and the nice thing then is that we're also backing out. So once you've picked a slope, then you've essentially picked an estimate of your pore volume. So you see if I change the slope up and down here, you'll see that the pore volumes are changing accordingly. So here a very steep slope is a small pore volume, and a very shallow slope is a higher pore volume. And you would like something that kind of matches your data right there. Here we're not trying to come up with the best type of analysis. We're trying to show you the mechanics. And if you click run, then we're backing out the average pressure and also the saturations at average reservoir pressure, and for both water and oil in this case. For the pressure, what you need to make sure is that your average reservoir pressure is always above the bottom hole pressures. The reason for that is, of course, if your bottom hole pressures are higher than the average pressure, then you picked up too small of a tank size. So that's a very good way for you to at least constrain your oil in place estimates and gas in place estimates on the low side. But in this case, it looks to be at least okay. We're more or less happy with how it fits our data right here. We're ignoring the last part of the data as we can't do much with it. And these numbers is what we're going to use to constrain our numerical RTA analysis.